Let's calculate the gradient of DC. The best thing to do in this case is to choose which point between C and D we are taking as 0.2 and which point we are taking as 0.1. So if we take point C as 0.1, we're going to have x1, y1. And then if we take D as our second point, we're going to have x2, y2. But whatever point you take as 0.1, 0.2, it really doesn't matter. We should get to the same answer ultimately. So let's go ahead and do that. The gradient of DC will be equals to y2 minus y1, everything divided by x2 minus x1. Sticking to the basics, right? So in our case, y2 is going to be minus 9 minus y1, which is 0. Everything divided by x2, which is 3, minus x1, which is minus 9. So this is equals to minus 9 divided by plus 12, right? And then if you put this in your calculator, or if you simply divide the numerator and the denominator by 3, you should get minus 3 divided by 4. So this right here is the gradient of DC. Sticking to the basics, nothing complicated really. And then the second question, 3.2, determine the equation of DC. So we're looking for the equation of DC in the form y is equals to mx plus c. Another equation that is very basic, right? No complications. We're just sticking to the basics here. We have 2 points C and D. We want to find the equation. So there shouldn't be no way to run this equation for ourselves. It's really straightforward. It doesn't require us to come up with any creativity whatsoever. But anyway, stories. Let's take a look. 3.2. So the gradient, we already know that it is minus 3 over 4 x plus c, right? And then we can substitute D, we can substitute C, and then find C, right? C, I mean the constant, and we will have our equation. So if we substitute C, I want to substitute C because I have 0 there and it is going to make my life simple. C has coordinates minus 9 and 0. So when we substitute it here, we're going to have the y value is 0, minus 3 over 4, x is minus 9, plus C. So we have 0 being equals to minus 3 multiplied by minus 9, that is plus 27, 9, 18, 27, right? Divided by 4 plus C. Should be easy to see that C is equals to minus 27 over 4. So what is y? Y is equals to minus 3 over 4x minus 27 over 4. There we go. We have the equation of DC. Sticking to the basics. Let's take a look at 3.3. So in 3.3, we're supposed to show that k is equals to minus 6. K is the y value at B, right? Is the y value at B. And B is a point that lies on the line CD. So we already have the equation. We know that B has coordinates minus 1 and k. If we substitute this in our equation, in place of y, we put k. And then in place of x, we substitute minus 1. And then minus 27 over 4. So k is equals to minus 3 multiplied by minus 1. That will be 3. So 3 over 4 minus 27 over 4. And then this is just a minus 24 over 4. 6, 12, 18, 24. So this is equals to minus 6. So there we go. Just like we're supposed to show. K is indeed equals to minus 6. What about 3.4? Calculate the length of DC. So if you take a look at this question, 3.1, 3.2 up to 3.4, there's really no creativity. We are just sticking to the basics, right? So in order to find DC, well, we have the distance formula being y2 minus y1 squared plus x2 minus x1 squared. But I'm going to take a shortcut here, if you allow me to do that. So take a look at this. y2 minus y1. We already have that when we were calculating the gradient, right? y2 minus y1 is minus 9. So here I have minus 9 squared plus x2 minus x1 is plus 12. So I have plus 12 squared. So now you just put that in your calculator, and DC is equals to 15 units, right? And then 3.5, calculate the ratio of dB over DC. Ratio of dB over DC. dB is a length, right? And the DC is also a length. Okay, so how can we solve this question? The problem that we have here is that we don't have the coordinates of B. That is a problem. Oh, well, at this point we do, because we have the value of K. We know fully well that it is minus 6. So we have the value of K. So option 1 is to calculate the length of dB, right? Because we already have the length of DC. DC is equals to 15 units. So we can just calculate the length of dB, and then we find the ratio of the two. We say dB over DC. And then there's another option. We can just rotate this. Oh, okay, I can't rotate this. I wanted to rotate the diagram here. But then if you rotate this diagram, this can be a straight line if you rotate it, right? Anti-clockwise. And then you just find the distance from C to B and the distance from B to D. But let's just calculate the length of dB. It's fine. So the length of dB, therefore, will be equals to y2. Let's take D as our second point. So we're going to have minus 9 minus 6, because K is minus 6, right? So that is plus 6 squared, plus x2, 3, plus 1 squared. Okay, so if you put this in your calculator, I mean, we have minus 9 plus 6, that is going to give us 3, and then 3 plus 1 is 4. So we have a triangle here. One side is 3, another is 4. The hypotenuse will be 5. So dB is 5 units. So dB over DC is equals to, what is dB? dB is 5, DC is 15. So this is equals to 1 over 3. So there we go. Right. I do realize that there are other ways we can use to solve this question. But if you get to 1 over 3 and then you didn't break any rule, you should probably be fine. And then that is 3.5. Let's take a look at 3.6. So 3.6, it's out of 4 marks. But for some reason, I did take more time thinking about 3.6 as compared to 3.7. I didn't take much time with 3.7 because we need to do a lot of things, but it is a very basic equation. We have seen such questions before. The problem was with 3.6. Maybe it has been there before, but I don't remember solving 3.6, so I had to really think. So let's take a look and see what is happening. If M is a point on AD, okay, so let me just erase some of this junk. M is a point on AD such that AC is parallel to MB. Calculate the ratio of the area of MBD divided by the area of ACD. So, okay, we need some point on AD such that AD and MB are parallel to each other. So, you can see that I'm using a ruler here. So, I just need to go down until I touch a point B, and then I will draw a line and put M. So there we go. I just need to put a line here, and here I have my coordinate M. So yeah, M is such that CAC and MB are parallel to each other. So there we go. I have M. But I want the area of this true triangle, MBD. So area of MBD, triangle MBD. So let's go ahead and take a look at triangle MBD. Let's just highlight triangle MBD, right? It's the smaller one. This is MBD. Let me change the color and take a look at the other triangle. The other triangle that we're interested in is triangle ACD. So ACD, right? We have two triangles here, and then MB is parallel to AC, and we want to find the ratio of the triangles. One thing that I realized is that, okay, in 3.5, I found the ratio of DB over DC. So I assume that is essential in 3.6. I might need to use that, right? So let's just keep it in mind that DB over DC is equals to 1 over 3. But we cannot calculate the area with just one side, right? We cannot calculate the area with just one side. We need two sides and the angle that they sandwich. Okay, but take a look at this. Let me show you something. I realized not fairly quick after some time. Not fairly quick. It was not quick. It took some time. So I realized that this true triangle, what is this point again? This is point D. This is point D. These two triangles are similar to each other. That's what I ended up realizing. Let me prove the similarity. First of all, in these two triangles, triangle AMBD and triangle ACD, you will realize that angle D is equals to angle D, right? That is just a common angle. This angle right here is just a common angle. Apart from that, you will realize that this angle here, right, angle MBD should be equals to angle ACD, right? Angle MBD should be equals to angle ACD. They should be equals to each other because the two lines AC is parallel to MB. So the two angles should be equal to each other. So we have proved that two pairs of angles are equal to each other. Of course, the third angle is going to be equal. So now we know that triangle MBD is similar to triangle ACD, right? Now we know that. But why is it essential for us to prove similarity? We want to prove similarity so that we can use proportions. We want to prove similarity so that we can use proportions, right? Proving similarity is the only thing that will allow us to use proportions here as far as this question is concerned. So let me show you what we are going to do. Therefore, we can say that we already know from the question above, right, that DB, well, what am I saying? That DB over DC is equals to 1 over 3, right? We already know that. But now we can play around with the other sides. Okay? So what can we say? We can say that, oh, okay, DB over DC, right, should be equals to, let's pick any other side. It is equals to, we can say DB over DC is equals to DM over DA, right? The other side, because we said that these divided by these, but now because we know that the true triangles are similar, we can now say these divided by this should also be equals to the ratio of the other sides. So this should also be equals to 1 over 3, right? And why are we saying that? Because the two triangles are similar. MBD is similar to triangle ACD. So we've proved that the two triangles are similar and that all the sides will be in proportion, therefore. But why are we doing that? Let me show you. We can say that the area of triangle MBD, the smaller triangle, right, is equals to half DB multiplied by DM, and then we say sine of angle D, right? Because angle D is the side, is the angle that those two sides sandwich. And then as far as the area of triangle ADC is concerned, we can say half, and then we use DC and DA, right? And then we take sine of the same angle because well, it is the same angle that is sandwiched by those two sides. So now we can proceed to the ratio and say that the area of triangle MBD over the area of triangle ADC is equals to a half dB dm sine of angle D. Everything divided by a half dC dA sine of angle D, right? So take a look at this. A half and a half cancels out, sine of angle D and sine of angle D cancels out. We are left with dB over dC multiplied by dm over dA. dB over dC, dB over dC. What is dB over dC? We know that dB is 1, right? 1 unit. And then dC, yeah. So from D to B, we know that it is 5 units. And then from D to C, let's take a look once more. Let me make sure that I'm not making any mistake here. From D to C, is it 3 units? From D to C, we had 15 here. From D to C, and then from D to B, we had 1, right? So, okay, everything is fine. So dB, we have 1 there, and then dC, we have 3, multiplied by dm. dm, same thing, right? 1 over 3. So we are going to have 1 multiplied by 1, which is 1, 3 multiplied by 3, which is 9. So the ratio of the area of the two triangles is 1 over 9. So there we go. That is 3.7. And then, 3.6 I meant. 3.7, it is further given that the gradient of AD is minus 4. So the gradient of AD is minus 4. And the length of AD is 612 units. So the length of AD is 612 units. So we can say that y, right, being the equation of AD is equals to minus 4x plus c. So let's take a look at AD. We do have the coordinates of D, which happen to be 3 and minus 9. Okay, so we can substitute this here, right, where y is minus 9 and then minus 4 multiplied by 3 plus c. So minus 9 is equals to minus 12 plus c. So 3 is equals to c. Okay, so we have y being equals to minus 4x plus 3 as the equation of the line AD. Okay, but we are looking for the coordinates of A. So now that we have the equation of AD, we can say that instead of having the coordinates of A as some x and y, we can say that A is x, but x being x, y should be minus 4x plus 3. This should not be groundbreaking. Should have come across something like this at some point of time. So those are the coordinates of A. Let's now use the other piece of information that we have to actually find the coordinates of A, because now we have the coordinates of A in terms of x and y, right? But we can use this distance to actually find the coordinates of A. So we can say that AD is equals to the square root of x2 minus x1. So let's take D as our second point. X2 is going to be 3. So we have 3 minus x squared, right? And then plus y2. Y2 is minus 9. So we have minus 9 minus 4x plus 3. So that is going to be plus 4x minus 3. Okay, so AD is equals to the square root of, let's not forget that we have AD. AD is square root of 612. So square root of 612. So we have 3 minus x squared, right? And then here we have plus minus 9 minus 3. Minus 9 minus 3, that is minus 12. So we have 4x minus 12 squared. So what do we want to do? We want to square both sides. So let's go ahead and do that. If we square both sides, we're going to get 612, right? And then we get rid of that square root, and then we just solve what's inside the brackets there. So when we solve that, minus x multiplied by minus x is x squared, and then we have minus 6x plus 9. That is that first part. And then the second part, seems like I need my calculator now. We have 4x multiplied by 4x, that is 16x squared. And then minus 12 multiplied by 4, that is minus 12 minus 24 minus 48. And we multiply that by 2, minus 96. So we have minus 96x and then plus 144. So 612 is equals to x squared minus 6x minus 96x. Oh, well, we have 16 here. It's 16 there. So let's write that as 17x squared and add those two. And then minus 6x minus 96x. So 96 plus 6, that is 102. So we have minus 102x. And then 9 plus 144. So 144 plus 10 is 154. So that is 153. So we have plus 153. And then we take 612 to the other side. Okay, so 17x squared minus 102x plus 153. I'm going to take my calculator. Clearly, I underestimated the problem. So we have 553 minus 612, which is minus 459, being equals to 0. So let me see if I can divide all these terms by 17. 459 divided by 17. Yeah, 17 is a factor of all these terms. So we have x squared 102 divided by 17 minus 6x 459 divided by 17 minus 27, being equals to 0. Factors of 27, 9, 18, 27, 9 and 3. Okay, so x plus 9, no, minus 9 multiplied by x plus 3. I think this works. Yes, so x is equals to 9, or x is equals to minus 3. But I like minus 3 because a is in the second quadrant, so its x value must be negative, right? So now that I have x, let me substitute it into minus 4x plus c. What is c? C is 3. Okay, so this should give us 15. So the coordinates of x is minus 3, y is 15. There we go. Tell me, which video should we do next?